Yeah, hi, good evening, everyone. So, welcome back to Plan 258. You know, this is the remaining agenda of our classes. Right, so, today we'll discuss about game theory. So, probably until here. Okay. So, about zero-sum games. And then, if we can finish, so we can continue with non-zero-sum games. Then, until how to control. Yeah. Based on game theory. I think we did not discuss this. So, group decision making and voting, cooperation games, and then we will discuss about IFN, power dynamic and extent. And these are the rest of the topic. So we will discuss also game theory and finance and economic analysis. And if we have time, so we can continue with time series analysis here. Okay. Uh, we have assignment. Okay. Last meeting that we did not have, and you requested to have study on your own. I using the video, and then I gave you the assignment. So, but not all of you did the assignment. Only a few. And so, please do the assignment. And if you have any question, you can ask me in the class. Okay. Okay, so let's discuss our first topic. Have you heard about the prediction on Iranian war by what's so-called Professor Jack? Okay. And he used what is called game theory, right? So what is game theory? Yeah, he make it as if game theory is social science. No, it is, but make it as if conspiracy theory. Yeah, but it is not. Yeah, game theory is a branch of economic and mathematics. Okay. So can you see the slide?
Yes, sir.
Yes. Okay. This slide is also in referred to in Moodle. So please follow from there. Okay. So, so in this lesson, we will define what is game theory, yeah? What is the objective and the assumption, and then the component of game theory. Yeah? So to give you the broader picture, we have discussed what is called decision analysis in this class. So we start with decision under uncertainty and certainty, and then risk and utility, and then the next topic is, of course, today we discuss about decision under conflict. It is called also game theory. Okay, and maybe next time we'll discuss about group decision making. Okay. So first, I give you motivation speaking scenario. So say you have a butler, okay, maid, yeah. So okay, that will buy food ingredient for your family, and then you say, this is the amount of money every week I provide for you. Manage it so that it will be enough for my family, and the remaining is yours. So that's the keyword. The remaining is yours. Okay, so now, if the butler take advantage by reducing the spending for your family and get more for himself or herself, my question is it the butler's fault or your fault in creating some system of zero-sum games. Yeah. So how to change the system so that the butler will be more responsible for your family than to himself. Is there any discussion on this? The point is your decision, eh, your communication with others, your performance evaluation can create a system. Yeah. And based on that system, then it may turn back as a karma to you. So then you can actually change the system so that it will not become like what uh, happened, but depends on how you create that system. It may become the system that uh, go according or go along with your expectation. Okay, so game theory is a study. Yeah? So in 1940s, okay, by von Neumann, yeah, and he created a very thick book of game theory. Okay, and he studied how the smart and ruthless people should act and interact in strategic settings. Okay? So in game theory, you will study how the strategic interaction among the individual, yeah, in two situations. Yeah, one is conflict, the other one is actually cooperating interest. Okay, so and we assume that everyone is rational. Okay, so uh, not only that, the next assumption in game theory is everyone is also conscious that their action will affect other people, and then other people action will also affect them. Okay, so that means, okay, that the individual also know, okay, what will be the effect of the outcome, and then it will act according to that knowledge. Okay, these are the assumptions of game theory. Uh, if you look at the number of people who won a Nobel Prize based on game theory alone, yeah, including Arsani, yeah, and Nash, John Nash. You have a movie, uh, Beautiful Mind, that's portrayed John Nash. Yeah. So, and many others. Okay. So this represent how important game theory is in economic and politics, including geopolitics. Yeah. So now game theory can be cooperative games and conflicting games. Yeah. So let's see what is the meaning of cooperative game. So cooperative game is a game where the players can make binding commitment. Yeah? So make agreement. Okay? And if we say non-cooperative games, yeah, they cannot make a binding commitment. Okay. Now, in cooperative games, you have two possibility. Yeah, with conflict or without conflict. So I will throw in here. So game theory, okay, you will put it as cooperative, co, and then competitive, competitive. Okay. Now here, with conflict or without conflict, yeah, without conflict. Competitive also have two, yeah, with conflict or without conflict. Without conflict. Okay, these are the big picture. So without conflict, so in cooperative game, so the member of this workforce, for example, will choose which equally difficult task to undertake the best coordinate with each other. So cooperative without conflict. Yeah. And there's also possibility cooperative game with conflict. For example, bargaining over the price. So there's a the buyer want the price as cheap as possible. The seller want the price as high as possible. So there's a conflict. Okay. Next is competitive game. So competitive game is also called strategy games. Okay. So one of example that we will play later, yeah, is called prisoner dilemma. Okay. This is a competitive game, so called prisoner dilemma. Okay. So two players, okay, say this blue and green here, they are both prisoner. Okay. Question is whether they will deny involvement in the crime or not. Yeah, whether they will confess or not. Okay, if they one deny involvement and the other one also deny, and then both will get 3 years. Yeah? But if the other one deny and the other one confess, okay, the one who confess go free, and the one who deny the investment will get 5 years, and so on. So these are the payoff matrix. Okay. So next is uh, competitive games uh, without conflict. So for example, uh, two or several companies will set a product standard, yeah, without actual binding commitment. Yeah. So this automatic happen. Okay. This is common in business and industry. Okay. Okay. So our focus for today is in this competitive game, yeah, or we call it strategic game. Yeah. So it's more competitive. So in the group decision making, okay, we are more focused on cooperative game. But let, for today, let's discuss about more on strategic game. Okay. So what we call as strategic game is competitive. That means at least you have two players. Okay. At least that means you can have more than two players. And each player has some choice of action or behavior. And then each choice will have one or more outcomes. Now, the final outcomes depends on the strategy, okay, chosen by all players, not just you, but all the players in the system. Okay? And individual decision have impact on each other. So this is what is called strategic interdependence. Yeah. So strategic game does not include game with pure chance. For example, lottery and so on, because in this case, whatever strategy does not matter. Okay, and also did not include single player. Yeah, so this is minimum two, not just one player. Okay, so what is the goal of game theory? So the goal of game theory uh, is to organize our knowledge and to increase our understanding of the outside world. Okay, and it has predictive power. Okay, you can predict based on game theory, and very interesting actually. Yeah. So how you predict using game theory? There are two types. Yeah. In transportation, uh, we have what is called Wardrop Principle, and Wardrop Principle 1 and Wardrop Principle 2. The Wardrop Principle 1 is basically Nash Equilibrium. Yeah? Nash Equilibrium. And Wardrop Principle 2 is basically Pareto Optimality. Yeah? Pareto Optimality. So what is this? Nash Equilibrium represent everybody is selfish, right? For example, in traffic. So everyone will choose their own route, okay, and then create traffic congestion. Okay, so that is called Nash equilibrium. Okay, and this is the actual behavior of the people without government intervention, yeah, without any control. Okay, so Nash equilibrium is what happened if you just let it be. Okay? So second is called Pareto optimality. So this is the jargon that you can search. Pareto optimality is the system optimal. Okay? You want to create the system that everyone will have good behavior. So this is by design. Okay? It will not happen unless you control something. Okay? So there are two things that you need to consider in game theory. Yeah, one is Nash equilibrium. So this is also in transportation. This is called Wardrop Principle 1, and this is called Wardrop Principle 2. Different terminology, but same meaning. Okay, so you have predictive power. Once you get the Nash equilibrium, you know what will happen. Okay. Next, to achieve this goal, okay, so game theory postulate some rules, yeah, to which individual will act or behave, okay. So you need to think what is their objective, okay, and how the rule of the games they try to achieve those objectives. Yeah. Because of this rule, then you can derive the prediction, yeah, at all of the given situation. So as usual, because this is called game theory, okay, you need to consider the assumption behind. Yes. So very important to understand the assumption behind mathematics. Okay. So in game theory, there is no mercy, there is no compassion. Okay, only self-interest. So remember, most people only care solely about themselves, and everyone knows and accept this. Okay, so what is the implication of self-interest? Yeah, so everyone will say what's in it for me, right? So example, yeah. So the employer will never give you a raise because it will be a nice thing to do. Okay, so during the threat later, yeah, we will discuss more detail about how to compute this. So you will get raise only if you can convince your employer that it serves his interest to give you more money. So things getting more interesting. Yeah. The same thing with our class. Yeah. So I said, beware, however, if you end up enjoying this lesson. Yeah. It is not because I teach it in the purpose of making you happy. Yeah. I teach it to maximize my own benefit. Yeah? So I don't care in any way about your welfare. But as a rational being, okay, I know what you want and you know what I want, so we can have some kind of Nash equilibrium between us. Okay. So next is the assumption. Remember, everyone is considered rational. Yeah. Individual is called rational if she or he has a well-defined objective, okay? Well-defined preference over the set of all possible outcomes. And then yeah, he or she will implement the best available strategy to pursue that objective. So this is the meaning of rational. Yeah, it's not just wishful thinking, but it will act accordingly. Okay, and not only that, there is also what is called information. Yeah, that means individual knows about all the strategy available to each other individual as well. So we have complete and consistent preference over all possible outcomes. Yeah, this is called game matrix. Okay, and they are also aware about this preference. Okay, so we know each other about the game, the rule of the game. Okay, and they can determine the best strategy for themselves. Okay, and then implement that strategy. So this is the main assumption. Okay, how if we violate this assumption? Later we can give you the example. Okay, during the thread. Okay? Later, that this is actually uh, become more interesting, yeah, if we have a partial information rather than full information. Okay. Next, when we say rational individual, yeah, so it is not enough, okay, that I know about my own action. Okay. It is not enough that I also know about your action will be. Okay. But we need to know that my action will actually affect the outcome, and I need to let you know that you know this fact. Okay? So the information should be not just within us, but also with other players as well. Okay? So this is an example of game matrix. Yeah, these are the payoff. I will usually use row and column to simplify. So say you have a course of action in war, okay? And first of all, you need to check all the possible action for each nation. For example, row 1, row 2, row 3. Yeah. And then for the column nation, what are the possible actions? Uh, column 1, column 2, column 3. Okay. And then if row 1 select this action and column 1 select this action, what will happen? Or it will be successful. Okay, so this is the game payoff belong to the row. Yeah. If you see this kind of game matrix, okay, is always belong to the row. This is the agreement. Okay? So that means if a row success, a column fail. Yeah. So this kind of payoff is called zero-sum games. Okay. If one win, the other one lose. Okay. Then the question is, which strategy is the best for the row nation and which strategy is the best for the column nation? So at this point, I will not show you how to compute yet, okay, but later we go to the technical. Okay, so I just want you to see what the game matrix look like, okay, and how you will develop that first, because that's probably the most important, so that you can apply this game theory in your life. Okay, so next, another example of military strategy. Okay, I will clean this up. Okay, so each nation does not know, okay, what the other nation's strategy will be selected. So the information is not known, but we know all the possible strategies. Yeah, this game matrix is known by both players. Okay, and both players know the complete plan of this previous matrix. Okay, this is the main assumption of game theory. And we also assume that the opponent also knows all this possible strategy and its payoff. Can be similar to ours. So the question to motivate you is why? Why we want to learn game theory? Yeah. So by learning game theory, okay, this is what I hope you will get from this lesson is when everyone are totally ruthless, extremely competitive, yeah, the logic of game theory often dictates that selfish people would cooperate and treat each other with loyalty and respect. And this is unexpected, yeah. Okay. So, and then you will also learn based on your move, okay, what you think other people might do. Okay. So by learning game theory, okay, you will think many steps ahead. Okay. So if your move is based on what our opponent might do, then their move is also based on what they think you are going to do, right? And then your move will in fact be somewhat based on what you think your opponent think that you will do, isn't it? So you will think several step ahead. Okay, this is what the main lesson of game theory. I hope you can get. Yeah, this two. Morality is not always uh, unselfish. Yeah, having self-interest is actually a good thing. Yeah, can be moral. This is the main part of game theory. It's okay. Now let's go to the part. Yeah? So what are the components? Okay. So of course, number one is a set of players. Yeah? Can minimum two. Yeah? Can be three, can be four, and so on. Yeah. And then each player will have action or behavior. And these are the choices. Okay. And then each action combination will have certain payoff. And then we also have what is called information. Yeah, so remember this four, yeah? So let's discuss it one by one, okay? So players are the stakeholders. Yeah? Can be individual, can be institution, can be organization, it can be a country. So, okay. So when we say individual, okay, it can be one person, can be uh, one group of people. Okay. So, and each player goal is to maximize his utility, yeah, by a choice of action. So remember, our assumption in here is each player are rational. Okay. And then the player will choose their move to maximize their payoff. Yeah. And each player always assume that other player is also trying to maximize their own payoff. Okay. Now you can also play games against nature, right? So if you play games against nature, yeah, uh, this is actually not a real player, but this is called pseudo player. Yeah. So in that case, it will take random action, okay, as the next example. Here. So in this example is one oil company against nature. Yeah. So the nature is the result. So it has two possible action, okay, to drill or to sell the equipment. Yeah. If the oil company drill and it found no oil, say it will lose 7 million. If it has oil, it will gain 10 million. Yeah. If they sell the equipment, it will earn just 1 million. Okay. But if they sell the equipment and actually there is an oil, so this is an opportunity cost, they will lose 5 million opportunity cost. So that question is, what is the best strategy in this case? Yeah. They can compute. Yeah. Again, the computation will be in the next slide, yeah, or in the calculator. So the question is, what is the best strategy in this case? To trail or to sell? Yeah. So the number of player, again, actually should be minimum two. Okay? Because if you have only one person that has been studied by decision analysis, yeah, under uncertainty and the risk under utility. Yeah. So in game theory, we study at least two uh, or n players. Okay. Okay. So the second component, yeah, so first component is player. The second component is action, yeah, behavior. So uh, each player move without knowing what the other player is going to do. But the action or the move by each player, yeah, so we can put it as AI, is the choice, yeah, that the player will make. Okay, so you have certain set of action, okay, and you can also combine. Okay, unless it's specified. Oh, now about the timing, yeah. Unless we specify clearly. So let's assume that the all the player will move simultaneously, yeah, at the same time. Yeah. It's not in sequential, yeah, but in simultaneously at the same time. Yeah, the timing. So when we say strategy, is the plan of action, yeah, for the player to maximize their payoff depending on the available information. Okay, so strategy is basically an action. Yeah. So, but sometimes the game become not just one game, but you have uh, a, a tree of games. Okay, then you will start to uh, say what is this strategy. Yeah? So in game one, this is the strategy, and then what will happen in the next game. Yeah? And so you create a decision tree, yeah, of the game theory, if you want to make it more complex. Yeah. So uh, then this is what is called strategy. Yeah, it's a plan of action for the games, and you have a complete set of instruction, yeah, based off the plan. In every conceivable situation, okay, what is the plan of action? When we say strategy, then the plan should be complete. Yeah? So that it cannot be upset by opponent action or by the nature. Okay. So what's the difference between action and strategy? Yeah, action is just one game, yeah, in a simple game. So you can observe. Yeah, strategy is unobservable because there are many possibilities, right? So you get a decision tree of the games. Okay? Action usually physical, yeah, but strategy is only plan, mental. Okay, so now the player strategy is the rule that tell him or her, okay, which action to choose in each instant of the game. Yeah, and then the third component is payoff. Yeah, so payoff represent the consequence. Okay, how much it is the uh, reward in money or probably in utility. Yeah, utility can be pleasure, satisfaction, and so preference. Okay, so there are two meaning of payoff. Yeah, first is actually utility of each player that they receive after all the player or the nature have picked up their strategy. Okay? Or okay, it is actually expected utility. Hmm? Not the actual utility, but the expected, so meaning the average utility. Yeah. So, okay. The payoff represent the outcomes. Yeah? So when we say the outcomes, that the outcome of the game, yeah, is a set of interesting elements, okay, that you will pick, okay, from the value of action and the payoff, okay, and the other variable in the game. Okay, after the game is played out. Now, based on these outcomes, okay, you can select what is called equilibrium. So what is equilibrium? Yeah? Equilibrium is a strategic combination, yeah, the best strategy for each of the n players in the game. Yeah? Say player A choose this action, player B choose another action, and so on. So the strategy combination of all these best action is called equilibrium. Okay? That means every player actually already maximizing their individual payoff, okay, by considering the others interaction. Okay. Equilibrium is the one that we predict. Okay. So once you know what is the equilibrium, so you will know what will be happening in reality. So given the equilibrium, yeah, we can see what action comes out of the conjunction, yeah? Combination of all the players' plan. Okay? Be careful, in game theory, equilibrium is not always exist and not always unique. Can have a possibility of one or two equilibrium can be zero, can be one, can be more than one. Okay? So the solution is not always unique. Okay? So next, you need to distinguish the big part of game theory, what is called zero sum and non-zero sum. Okay. So in competitive game or strategic games, yeah, when we say zero sum, that means your winning is just equal as your opponent losses. Okay. So then you can put this on the left hand side. So you minus, that means that the sum, okay, is zero. That's why this is called zero sum. Yeah. So your payoff plus your opponent payoff, okay, is all zero. Okay. This is very competitive game. Okay? So in sport, usually we do this, right? Only one is the winner. Yeah. In zero sum game, yeah, you have at least two players. Okay. And the payoff of player A and the payoff of player B, if you sum, becomes zero. Yeah. Because you the sum is zero, so you can just simplify into one single game matrix. Okay. Now, if you have three players, for example, in trading, you have trader A, trader B, and broker. Yeah. So, this is all if you sum up all the payoff, it becomes zero. Okay. So this is the example of game matrix in zero sum game. Yeah, usually I will use this kind of jargon, so I will put it as Miss Row and Mr. Column to represent that this is actually players. Yeah, so if you see game matrix like this with only one number in each cell, okay, this is called zero sum game. Okay, so and by agreement, this numbers is the payoff for Miss Row and not for Mr. Column. Then what is the payoff for Mr. Column? It's just the negative of this. Remember, zero sum game, yeah? So if Miss Row get 4, that Mr. Column will get -4. Yeah, if Miss Row get 2, then Mr. Column get -2 and so on. How about this one? 5, -5. Miss Row get -5, meaning lose. That means Mr. Column will win 5. Clear? So then how to get the equilibrium? Yeah. So to get the equilibrium, okay, in this zero sum game, you will do this one. Yeah. First, you check Miss Row will maximize the minimum row. Yeah. So you find the minimum in each row. So 6 and 5, what is the minimum? 5, right? 5 and 4, what is the minimum? 4. Okay. Mr. Column will minimize, be careful, yeah. So Mr. Row will maximize the minimum. Mr. Column will minimize the maximum. So first, you will maximize, Mr. Column will maximize the value in each column. So 6 and 5, maximum is 6. 5 and 4, the maximum is 5. Yeah. So And then Miss Row will maximize the minimum. So this is the minimum. What is the maximum? 5. Yeah. This is the maximum. What is the minimum? 5. Okay. So if and only if the number, yeah, the maximin and the minimax are the same, then you get equilibrium. Yeah, that equilibrium is also called game value. So where is the equilibrium here? This one. Yeah. So this is the one in red here. Is this cell is the equilibrium. That means Miss Row will do action A, okay, and Mr. Column will do action D. So this is the prediction. Yeah. So given this game matrix, okay, what they will behave, what action they will take. So you will know, yeah, because you know you found the equilibrium, then you can predict what is the action. Is this something useful? So you can predict already. Huh? Next, uh, is non-zero sum game. So how you will know that? Yes, George, you want to ask something.
Uh, Sir, is it possible for both players to have a zero payoff outcome? So it's like, can this be considered a draw where no one wins or no one lose?
Possible,
Or
possible.
is it considered still a Nash equilibrium?
Uh, in zero-sum game, we did not discuss Nash equilibrium. Okay, so we just say minimax equal to maximin, then you have game value. Yeah. So when you have a zero payoff, that means uh, remember earlier I discussed here that where is that? Here, yeah. So the meaning of payoff can be two meaning. Yeah? One is the actual utility or actually expected utility. Okay, so when every value in the payoff is actually 0, 0, as you asked, that is probably expected utility, yeah, not the actual utility of the player. Yeah, so the actual utility can be non-zero, but when you calculate as average, can be 0. That's probably the case. To answer your question. Okay, so a while ago I discussed zero-sum games, something like this, right? And if you want to find equilibrium, not always exists. If exists, then minimax equal to maximum. Second type of game is called, this is more general, this is called non-zero-sum game. Okay? That means, okay, in itself, yeah, you will have the payoff for each player. Okay, so in here 1, 1, that means the first number belong to the row, the second number belong to the column. Yeah, so in here 0, 2, that means if Miss Row select action A and Mr. Column select action E, yeah, Miss Row will get 0 and Mr. Column will get 2. Is it clear or not? How about this one? Yeah. -1, 1, what's the meaning? If Miss Row select action C and Mr. Column select action F, okay, Miss Row will lose 1, okay, minus will lose, and Mr. Column will win 1. Yeah, one can be the money, the value here can be money, can be utility. Yeah, so it's an ordinal value. Is it clear? So from here, you can actually represent this as decision tree. Okay, so say you have this kind of table. Yeah, this is the game called Battle of Sexes. Yeah, later we'll discuss when we discuss non-zero sum games. Okay, and we can put this kind of matrix into a decision tree. Yeah, so how to put that? First, you put this row here, okay, and then you see the action. Yeah, the action is I put here top and bottom. Of course, you can change this in top and bottom here, and then the next is Mr. Column. Yeah, Mr. Column have 2 possibilities, left and right. Okay, so and then in the leaf nodes, okay, you have the outcomes. So these are the outcomes that you put down. Okay, so game matrix can be represented as 3, yeah, like decision tree, similar to the one that we discussed last time. So the fourth component, yeah, is information. So what is this? Yeah? A set of players, yeah, they usually have certain knowledge, okay, at certain time about the values, yeah, maybe different variables that people will think about, yeah. So then these values that make distinction between the variables, okay, is called player information. You know something that the other people do not know. Yeah? Or the other people know something that you do not. Yeah, that is the one that make things different. Okay, so the information set can change the course of the game. Yeah? So here is the example. Yeah? Threat. So information will play an important role on threat. Yeah? This is an example. Yeah? So say you are a grade school teacher. You have a lot of young children, okay, and then some of the children did not behave well. For example, they are fighting. Yeah. Then it is actually in your self-interest not to inform the parent, okay, about that child misbehave. Why? Because first it will upset the parent, okay, and then second, actually, if the children have bad behavior, it is most probably your own fault as a teacher, yeah, because you probably did not act as the real teacher in this case, yeah. So then what you will do, yeah, so that the children will behave, then the teacher probably will threaten the children, yeah, to behave, or else I will report to your parent. Okay, so this is the decision tree. Okay, then look at the information here. Yeah? The children does not know the teacher's self-interest. Yeah. That's why they behave. Okay. But if the children knew what is the teacher's self-interest, they probably will not behave. Okay. So that from the child point of view, okay, they can choose to behave or not to behave. Yeah. And me as the teacher to tell the parent or not tell the parent. Okay. So you can put numbers here, then you will see, okay, what is the decision. Okay, so I created also game theory calculator. This is not something new. Other people also made game theory calculator. Yeah, but this is from others. And uh, there are many quotes on game theory. Yeah? And what you will learn, at least from game theory, is actually empathy. Yeah. So by putting yourself in other people's shoes, because in game theory will train you to think from other people's point of view, not just from yourself. Yeah. Okay, this is the introduction of game theory. Now, do you want to play a game? Okay, so I have a game here. So this is called Prisoner Dilemma game. Can you see my slide? Okay, you see it? Let's play a game. Okay, so the purpose of this game is to reveal your way of thinking, yeah, through cooperation, competition, trust, and negotiation. Okay, I will open Excel. Okay, so you can choose either to cooperate or to betray the other team. And I need to remind you first, okay? Uh, do not feel bad if your team is betrayed by the others, okay? Remember, this is only game. Is that okay? So can you open your camera? So, and I want you to uh, make a team, yeah? So how many teams you want to three teams probably, or we are nine, right? So three teams, is that okay? Or no, okay. Two teams or four teams or three teams is up to you. So let's prepare to play the games. So the class is divided into teams, okay? And then we will play 6 rounds, and let's name the team A, B, C, D if you have more person. So each team is 2 person. Is that okay? Or how many groups are you in the project?
4, sir.
4, or you already merged? Okay, 4. So let's make 4 teams. Okay. And then I will give you time to discuss just 1 minute or 3. Okay, so let's make a 3 teams then. Yeah. So each team will discuss maximum 1 minute, yeah, to vote only. Very easy. Just vote. Okay. And in voting, you only chat to me. Okay. You will not discuss the vote between teams. Yeah. Yeah. In the real class, we will use paper, but we are online, so you can just chat me your team's vote. Yeah, one team, one representative. Okay, so we will play 6 rounds. Okay, and only at round 3 and round 5, each team will represent. Team representative can discuss between teams. Is it clear or no? Okay. Okay. So this is the game objective and the rule of the game. So game objective is simple. Yeah. You want to get the highest score for your team, and your vote is either X or Y. Okay, but not both. Yeah. So, and then if all teams, we have 3 teams, right? If all teams vote for Y, okay, that means we have 3 players, 3 teams. If all teams vote for Y, no teams will get any points. So you all get 0. Hmm? If all teams vote for X, each team will get 4 points. Now, if there is a mixture of vote, yeah, say one team said X, the other one said Y. Okay? So those who vote for X will get nothing, 0. Okay? But those who vote for Y will get 5 points. Okay. Is that clear? Shall we start the game? Okay. So can you record the game rule? So I will not share anymore. Okay. In 1 minute, okay, the team representative will chat me personally, yeah, about your own vote, X or Y. You see, you can discuss among yourself within a team, yeah, not between team. Okay, X or Y. Go. Let me write down your decision. Uh, you need to tell me uh, your team number, and 1, 2, 3, so that I can type here. So I will have round. Okay. And group. Okay. So group 1, 2, and 3, right? So round 1, we have 6 rounds. Okay. Uh, group. Oh, you did not. Group George. What group are you?
Group 2, sir.
Okay, group 2. Okay. And then Korean is the same, right? How about the other group? Just EC or just X or Y. Mhm. So, group 3, okay. And group 1, what is your decision? Just X or Y only. Hmm? Did not make? Who is group 1?
Sir, there has been a merging of two groups.
Ah, okay. Cool. So you discuss among yourselves. What is your decision, X or Y? Okay. So I will reveal your decision. Okay. We'll share there. So what is the scoring? Oh, because we have a mixture, right, of X and Y. Okay. So that means 1, 2, 3 here. So because we have mixture of X and Y, so group 1 will get 5, right? Group 2 will get 5. And group 3, you choose for X, so you get 0. So who is the winner of this round? Group 1 and group 2. Okay. So let's go to round 2. I will not reveal again. Easy games. Ah, okay. Easy games. Okay. Discuss among yourself. Remember, in 6 rounds, you're supposed to win. Yeah, the total. Okay. So, okay. Discuss among yourself in 1 minute. You tell me. Okay. So I will put everyone here. So round 2. Okay. Round 2. Okay. What is your decision? So you need to think before you put your group number so that I will know. Thomas is group 1. Is that Thomas?
Yes, sir. Group 1 kami, sir.
Okay, okay. Group 1. Okay. And group 2 is very fast. Oh, group 3, come on. Did you finish discussion? Not yet. Okay, we will wait, no problem. It's just to decide X and Y is so difficult. Yeah.
Sir, can we clarify who
Mhm.
belong to group 3?
Oh, I don't know. Group 1 is Tommy, Lester, and Andro. Okay. And who is belong to group?
Dian also, sir.
Oh, okay. Diane. So who belong to group 3? refill yourself. So a while ago, who is group 3? Diane, you for this game only, so you already put group 3 okay, a while ago, so can you remain in the same group? We are just playing games anyway. So what's your group decision? Group 3? Okay, okay. So Diane is alone in this case. And now let's reveal the result. Oh, so the scoring, you get group 1 get 5, right? Group 2x, so get 0. Group 3y, so get 5. So the accumulation become 10, right? And then this one become 5. And this one become 5. Oh, group 1, you are the winner in round 2. Okay. So before round 3, I want you to discuss among yourself between teams. Okay. What is the best decision? Okay. So now you can cooperate, no need to make a competition. Okay. In round 3. Okay, but your agreement is non-binding. That means you can betray each other. That's fine. This is just games. Yeah. So go and make a discussion. Yeah. You can discuss openly, no problem. What is the best? What do you think? Oh, you cannot because anyway, it's one only. Finish discussion? You don't want to discuss or you?
Group 2, vote for X so we can all have points.
That's the uh, agreement, right? But that is non-binding, okay? Is that okay? Yeah, group 2 for X, and then everyone will get, or you want to sacrifice one team, so that's okay. Or you want everyone to win, so. What is your thinking? Go ahead. What do you think? You know each other, right, in the class? So, finish discussion. Okay. So, if finished discussion, let's play the game. Round 3. Okay, I will not reveal anymore this computation. So, then you chat me in round 3. Oh, where is the round 3? So I will put here so that I will know this is the. So I will put round 3. Okay, then tell me the vote. Okay. So group 1, round 3, group 2, round 3, and group 3 is only one. Say, Diane, what is your decision? Okay. So now I will reveal your vote. Yeah. After you make a non-binding agreement among yourself, yeah, what is the result of your discussion? So I will show you. Did you see? This is your fault. Because all y, what will happen? All zero.
0.
All zero. Okay, all zero. This is called a crab mentality. Okay. But because of this, so group 1 still win 10. Right. Okay, so now round 4. So this is the one with discussion. So I will point this yellow. Okay. So round 4, no discussion. Okay, I will write here for everyone. Round 4. Okay. Now discuss within your own team. Okay. What is the best strategy to win? You can still win, at least you can put tie, isn't it? You're very competitive, right? Okay. So I will not share what will be your decision. Group 1. Okay. Group 2. Okay. And group 3. Okay. You make decision. Okay. This is what happened. Da da da. Okay. So you get 5. You get 5. Ryan, why you choose X? You sacrifice yourself.
Peer pressure.
Yeah, sure. She sacrificed herself. Okay, so revenge time. I will close again. Round 5. I will write I have in here so that this is marking. Round 5. Think wisely about your own decision. So the winner still group 1, yeah? 15. This time, so this time, uh, wow, excellent. Yeah, this is what happened. Da da da. Everyone got 0. Okay. This is very funny. Okay, don't feel bad, huh? Yeah, this is the Nash Equilibrium, you know. Okay, so before round 6, the last, yeah. So you can have discussion between teams, yeah. So what happened? What is the best? You can have discussion between team. So round 6, yeah, last. And then you fold, yeah? So I will not refill again. Okay. Uh, okay. And group 1. Yeah. A lot of members, so difficult to decide. Let me see. Okay. Okay. So now I refill. Right. Da da da. There, your decision. So you get 0 and 0. No, no. Is that correct? And no, x is 0. This one is 5, and this one is 5. Is that correct? So group 1 still winning, 20. And the other get 10 and 10. Okay, so why we play this game? Okay, this is the most important part, is the lesson. Okay, so why we play this game? Uh, can you calculate the sum of all? 40, correct? 40 for this is the society score is actually 20 plus 10 plus 10, that's 20. So what is the best score for all? The best score for all is if you all play X, isn't it? So if you all play X, that means you will have 4, 4, 4. Yeah, that means 12 times 6, right? That means you will have 12 times 6. You're supposed to get 72. Yeah, okay. But the class score is only 40 divided by this one. So your class score is only 55. 55%. Yeah, because you don't cooperate, because you are very competitive. Yeah. Yes, you are as individual, as your team, you win. Yeah. But as a society, you lose. Is it good lesson? Why? Okay. The bigger part of yours society, maybe your community, your country, lose because everyone compete in this kind of game. Do you understand? Yeah. It look like harmless games. Yeah, just X and Y. 24 point each. 24 point each. Sorry. Apple, can you see? What is the meaning of 24 point each?
For each group, we can get 24 points if we vote for X.
Hmm.
Yeah, I just replied earlier before.
Yes, yes, yes. Okay,
Yeah,
thank
yeah.
you. So, yeah, 24 times 3, that's 72, right? That's correct, yes. So, but yes, the winner almost reached that 24, yeah, but the others lose because of competition, yeah. So, yeah, it's a simple games. Now, can we change this? Can we change this so that everyone will select, okay? Everyone will select automatically without, even if you're very competitive, everyone will select to trust each other. Hmm. What you will change? What you will change is actually the rule of the game. Okay? What is the rule of the game? Instead of prisoner dilemma games, okay, so I created a new game. Can you see my screen here? Trust game. Yeah. So the game play is exactly the same. Okay, exactly the same. So 6 now. Yeah. Okay. X mean trustable, Y mean cheap, right? So again, you want to get the highest score for your own team. Exactly the same. What make it different? What make it different is actually the scoring. Look like the same but different. Okay. If all team vote for Y, no team get any point. Yeah. If all team vote for X, all team get 4 points. And if there is a mixture of vote, those who vote for X will get 5, those for vote for Y will get 0. Think about it. Do you want to play or you already know? What do you think? No response. So, okay, let's play so that you know. Okay, let's play again. This time, I will put in the chat. Round 1 again, okay? The same team. So, round 1, city, game of trust. So, what you will choose? Rationally. Mhm, mhm. Yes. So, you all choose for X, isn't it? Yeah. So, no matter how many times we make a round, you will choose X. Society will benefit from this. You will get 72. Question: what make it different between earlier game and this game? Yeah, this is earlier game. This is the game matrix, and uh, this game, this is the game matrix. Can you see the difference? I only reverse a little bit here. Hmm. So earlier, okay, if you betray, if you cheat, yeah, you will get higher score, right? In here, if you cheat, you will lose. So look at this. In the society, okay, when the right things get reward, the wrong thing get punished, that will create trust game. That's why morality is important. Okay. If the one who get cheat get reward, the one who do right get punished, the society collapse automatically, rationally. Interesting. So performance evaluation matters. Yeah. In your office, right? So say you work very hard and your uh, group mate, just lazy, yeah, and they get reward more than you, then you will get demotivation, isn't it? Then eventually the system will collapse. Yeah? The company will go bankrupt. Rationally, because everyone is selfish, does not mean that they cannot cooperate. Okay, tell me the discussion. So, what did you learn based on this simple game theory? Yeah? I hope by playing this game, then you understand better. Now, go ahead if you want something to discuss. Yes, George.
Sir, are you asking about what I have learned?
Yes.
Okay. I think, sir, for this game, I learned that my decision depends not only on myself, but also with the other team members, other players.
Okay. From the game that we just played, so how is your feeling? Why you make that decision, X and Y, a while ago?
This is the decision of the group, sir.
Yes, but why?
I think because of the benefits that maybe we will win the game if we choose this option.
Right. Because I told you your team is important more than the society. Right. So the meaning is education matters, leadership matters. Correct? If the leadership, you do your best within your department, not for the whole, right? Then you will do best within your team, not for the whole. Is that right? So the way to set the frame and the communication matters. Correct, eh? Okay, good. So is there anything else you want to discuss? What did you learn? So if not, let's go to the next slide here. Okay, modeling game theory, the next slide. Yeah, this is a kind of workshop. Yeah, that I have a lot of practices here. Yes. So Diane said, when you trust that they will do the things that will benefit all, and in the end they did not meet the expectation, you will guess your decision and hope you will not lose next round. So you will become more defensive. There will be time where we need to cooperate with the wider group. That's correct. Yeah. So uh, okay. In this simple lesson, okay, we will learn how to create the K matrix. Yeah, you will practice how to create K matrix, and then what is the meaning of that K matrix. So I hope you can develop your own K matrix. Okay, non-technical, still just conceptual. Okay, so remember, this is the one that I explained a while ago. So we will deal with zero-sum games. Okay, so the row here means the choices of Miss Row. The column here is the choice of Mr. Column. Okay, and these numbers here, the payoff, represent the game for Miss Row. Okay, so what is the meaning of this zero here? Yeah, this is what George was asking about. Yeah, so this 0, 0, that means expected. Yeah, it doesn't mean that the actual value is 0, but this is expected payoff. So probably the actual payoff is not 0, but when you sum or the average, you will get 0. Yeah. So that's the meaning of 0 here. So everyone gets 0 in this game. So in this case, if you put minimax, maximum, minimax and maximin, you will get all these 4 as the equilibrium. And how about this one? What is the meaning of 2, 2, 2, 2? So if you see the game payoff like this, and these 2 belong to Miss Row, right? That means Mr. Column does not want to play this game. Suppose, yeah? So because Mr. Column is always lose, because this is unfair game, yeah? 2 is for Miss Row, that means for Mr. Column become -2, -2, -2, -2. Yeah? Whatever choice that Mr. Column do, either C or D, yeah, Mr. Column always lose. Yeah? So regardless what strategy it is. Okay? So you don't want to enter this kind of game. Yeah? Next. Yeah, this is the games against nature. Can you find minimax and maximin in this game? So if you take the max of -7 and 1, you get 1. 10 and -5, you get 10, right? And then this one maximum. And here you get mean. So minimum of -7 and 10 is -7. minimum of 1 and -5 is -5. Yeah, there is no intersection. So this is the game that there is no simple equilibrium. Yeah, this is oil company against nature. Oh, how about the rock, scissors, paper game? Yeah, so if you put rock, scissors, paper game, so you can make it this way, right? So the diagonal will be all 0. So this is for Miss Row. So if Miss Row plays scissor and Mr. Column play paper, so Miss Row will win, right? So win is 1 and lose is -1. Is this clear? Okay. So next one you need to practice. So I have two nations, yeah, row and column. Okay, and then these are the map. Okay, so we have A, B, C, D. These are probably the path point, the waypoints. Okay, so these are the path for row, and this is the path for column. The question is simple. Yeah. What is the size of the K matrix? Anyone knows what is the size of the K matrix? Given this problem, what is the size of this K matrix? So look at the path for row, yeah, from row and then go to B and then go to BAC. Oh, from meaning this B mean from row go to B and then attack columnation, right? And BAC means from here go to B and then go to A and then C and then attack columnation. Yes, George.
9 row and 5 column. It means your 9 by 5 matrix. So it means
Yes.
45.
Yeah,
9 by 5. 9 by 5. Yeah.
Yeah, 9 by 5 cell, yeah, 45 cells. That's correct. Yeah. So the size depends on the all possible choices, which not necessarily the same. Yeah, very good. Yeah, that's the also. Yeah. Good, good. Now understand, yeah. Next. Yeah, this is the example of the game matrix, yeah. So what's the meaning of this number, yeah? So -8 here, for example. That means a row will choose this path, okay, and the column will choose this path, BA, yeah, and then this number minus, that means for the row, that means Miss Row will lose, yeah, and columns will win, and so on. Okay, let's make it more complex. Now, how about this one? 3 here. 3 here means if row using this path and the column using this path, okay, so row will win 3 points. Okay. Yes, correct. So positive mean row win. Correct. Yeah. Very good. So now uh, let's do a cat and mouse game. Okay. Yeah. So I'll give you maybe 5 minutes, so you can also rest a little bit. Yeah. To do this practice. Okay. So can you develop all the possible pure strategy and create the game matrix of this game? Yeah. So the cat enter from here, this corner, yeah, and the mouse enter from this corner. Yeah, this is the blind maze. Yeah. So and the cat can so one of this is like this. Okay. This is the movement, possible movement. Yeah. So they may turn in the each corner here, they can turn in the corner, but they cannot turn around. Yeah. Just can go straight or go left or right, but cannot U-turn. Okay. And they travel at the same speed. So that means only three links like this. Yeah. And they are given enough time to cover only 1/4 of the maze. So only three links. Yeah, three consecutive step only. Yeah, but when the cat meet the mouse, of course the mouse will be eaten by the cat. Okay, so but if in three steps the cat did not catch the mouse will be rescued. Yeah, so can you try this game? Okay. Okay, so the time is start now. So can you try to make the game matrix? Okay. Then you can share screen. Get done. So when it is done, you can share your game matrix. Yeah. Then okay, so it's continue then. Good. Andrea, you want to share the class?
Hello, sir.
Hello, can you share your
So,
screen?
can my screen be seen?
Yes. Good.
Hello, sir. So, I filled up first all the possible moves. Since the limit is
3.
the mouse wins in 3 steps, so I just limited all the moves to 3, and then simulated in my mind when they will bump each other.
Powerful. Excellent. So
So it seems when the cat uh goes to the center, most of the time the cat will win.
already,
That's what I I intuitively think. Yes, sir.
this one, is it correct? Yeah, the second one.
Second.
Oh,
Wait,
very,
sir.
very. So, because your card is in the column, yeah?
Yes, sir. Yes.
Wait. So, yeah. Anyway, so I have, if you look at the next slide, okay, that's my answer. I don't know if much or not with your answer. Okay, so the way I do, so I draw this one by one. So basically, because two exponent to 3, that means you have only 8 possible pure strategy. So let's call this strategy 1 to 8. So yes, yeah, that's correct. So separate, yeah, between the cat and the mouse. Okay, so they are not in the same. I just throw it this way, but actually they are separate. So that I just name it 1 and so on, but the 8 possibilities. So these are all possible movement of the cat, and here is all possible movement of the mouse, right? Okay, and then from here you make 8 by 8 matrix, right? Oops. So we make 8 by 8 matrix, that is supposed to be this one. So the mouse never wins, so okay, so there is no -1. So this become binary, 0 and 1, or win and lose. For the cup in here, because I put cup here. In your case, you put in the row mouse, so in that case, you're supposed to make it -1, right? And 0. Okay. So with this, I also put this into the calculator. Yeah, so that is game theory calculator. So if you join the again in Revoledo, okay, so you can go to the main revoledo.com, okay, and you join, and you go to the bottom, you will see game theory and strategic analysis. There are two calculators there. Yeah. This is the game theory that we discussed, and this is for the coalition. And this is the assignment that we have yesterday. So in this assignment, you put it here. This is the assignment that you have, right? You're supposed to make 50, 49, and 1, right? So once you put that, so you will have this value. Yeah. So 50, you will have fatal power, okay? And there is no dummy. Yeah. Because to make 51, you still need the weak player. Okay. For today, and this is the game theory tutorial and virtual lab. So I selected, if you click here, cat and mouse puzzle, so you will have the answer. Yeah. And there are many other examples of the games that you can play. Yeah. Okay. And if you want to choose several player, so you can select, for example, if you have 3 player and you click this one, and then you go down here, this is the answer. Yeah. So if you have 3 player, so you will have this is the game matrix for 3 players, because this is 8 by 8. So let's make it simple. I will make it 2 by 2 so that you can see clearly. 2 by 2. Okay. So let's simulate 3 player. There. If you have 2 by 2, 3 players, so you will have, this is the value example of each player. Yeah? Because 3 players, 1, 2, 3. So, and then you calculate the equilibrium, so you get the answer here. Okay. And if you have 4 player, same, click this one. Then, because 4 players, so you will have 4 numbers, yeah, separated by comma. So you need to create combination. And if you click this, like calculate equilibrium, you will get the expected payoff for each player. Okay. Okay, so let's come back to the simplest 2 by 2 first. Okay. There. Now, if you have 2 by 2, yeah, so you can click here and type your numbers. And then click this blue to get the actual values. Yeah. So this is the game of pure strategy. This is the Pareto Optimality. And yeah, we will discuss in a moment again whether this is zero sum or not. Yeah, it will compute. And this is the equilibrium. Yeah. So, and you can read more detail about the meaning. Yeah. Okay, let's come back to the slide. So, I showed you a while ago the rock, scissors, paper. Okay. So let's modify the rock, scissors, paper. This is the rock, scissors, paper. Yeah. let's modify the rock, scissors, paper into a new games of our own. Okay. What will happen? Can you make that game matrix for Miss Row and Mr. Column? Okay. So let's modify the rock, scissors, paper so that the scissor is always larger than the paper and larger than the rock. Yeah, so that is still cycle. Okay. But if you win using scissor, you get 3 points. If you win using rock, you get 2 points. And if you win using paper, you get 1 point. And if you lose or draw, you get 0 point. So what will be the K matrix if we modify? Okay. So this is becoming more interesting. Anyone want to try? Show this. Yeah, it's a simple game, rock, scissors, paper. So the purpose of this practice is so that you can create your own game matrix. Let's practice. Yes. Okay. Andrew, you want to share and explain? I will stop sharing.
Hello.
Yes.
So as per the instruction, when the Caesar wins, it always gets 3. Wait, okay. Wait, sorry. Maybe this is minus or
Uh, there is no minus.
okay. So I just took the minimum of each row and max all the columns, and I get an intersection
Oh,
of the 3.
actually, my point is if you modify this game, it is no longer become zero-sum game. You still have the same sequence. Okay? That scissor is win over paper and over rock. Okay? But if you play using scissor, okay, you get 3 points. Usually you get 1 point, right? So, okay, if you
Okay, I will review, sir. Sorry.
okay. So the point of this practice is to show you when you modify the games, suddenly you will create from zero-sum game, you will create non-zero-sum games. So it will become 2 numbers. Okay, no problem. Yes, Lester, you want to share your screen? Explain.
Hello, sir. Hello,
Hmm.
Prof.
Yes.
Based on the instructions, when you win using a scissor, you'll get 3 points, and then when you win using a rock, you'll get 2 points, and then when you win using a paper, you'll get a point.
Yes.
So in this matrix, it was revised to reflect the points that Miss Row and Mr. Column will get using scissors, paper, or rock.
Yeah.
So for instance, if Miss Row chooses scissor and then Mr. Column chooses paper, then in this cell you can see that Miss Row will get 3 points while Mr. Paper would get 0 point.
Yes.
And on another scenario, for example, if Mrs. Row chooses scissor and Mr. Column chooses rock, Miss Row will not get any point, but Mr. Column will get 2 points.
Correct.
Well, this is the matrix which applies to the conditions.
Yes. Very good. Yeah. Very good. Right. So this is the correct answer. Yeah. Okay. So next practice. This is based on story. There are two elderly person, Frank and his wife. Okay. So Frank did not remember if today is his wife's birthday or not. Okay. And then he goes home late. Okay. And everything is closed except the florist. So then the question is whether he should buy birthday gift or not. Should buy the flower or not. Okay. So if let me share with you. If it is not her birthday, okay, and it bring no gift, then it is okay, right? Yeah, so the payoff is 0. If it is not her birthday and he bring gift, she may get confused but happy. Yeah, so let's put +1. But if it is her birthday and he bring no gift, then she may get upset. Yeah, so this in this case -10. Yeah? And if it is her birthday and he brings only flower, yeah, uh, she might be happier. Just 1.5 positive, yeah, bigger than this one. So can you create game matrix based on this story? Yes. Okay. Yeah. Yes. Something like this. Yeah. Very good. Lester. Yeah. So, is anyone okay with this kind of practice? So now you can think about your own situation, also in your project, okay? And you can select the possible action, okay, between you and your clients or with the community and so on. Then you can start to create your own game matrix. Yeah. So then you can present next time, yeah, in your workshop, yeah, for the project. Okay. So yeah. So basically what we just did is you develop, yeah, the game matrix, yeah, by considering all the possible strategies, yeah, the path. Okay. Now let's go to the technical, okay, where we put the numbers. So this slide is done. Let me go to the next slide. So let's start with the solution of zero-sum games. Okay. So yes, there are a lot of calculator. I also make calculator there, but I think if you understand the concept, yeah, even in we can connect this with the linear programming that you learned last time. Okay, so if you understand the concept, then you can see the dot. Yeah, you can see the connection of the dot. Okay. Okay, so you will learn several terminology. Yeah, first is saddle point, and then the value of the games, and one technique is called domination. Yeah, and you need to distinguish between what is called pure strategy and mixed strategy. Yeah, pure strategy and mixed strategy, and then we can practice using Excel. Yeah, and lastly about scaling property of game matrix. Okay, so when you have a zero-sum games, okay, you have a single game matrix. Yeah? Single mean only one numbers in each set. Okay, so and you know this number represent the payoff for Miss Row. Okay, and question: what if you have this game? Yeah. So if Miss Row select A and Mr. Column select C, okay, Miss Row will win 6, and Mr. Column will lose 6. Yeah. So both will play safe. You remember during our decision under uncertainty, when someone plays safe, okay, we remember what is called minimax and maximin. Okay, so then the row strategy will find the minimum in each row. You get the minimum first, okay, and then you get the maximum. Yeah, you get the minimum first in each row, and then you get the maximum among all the minimum. Okay, so then the strategy of the row is maximum, right? So the argument of the maximum. Yeah. So in this example, okay, so 6 and 5, the minimum is 5. 5 and 4, the minimum is 4. Okay, and then you get the maximum among the minimum, so 5. Yeah, so I put star here. And this is the choice of Miss Row. Yeah, Miss Row will play A. How about column? Column will do minimax. Yeah. So why? Because remember, for column, this is the negative. Okay, not the actual number there, but this is the negative. So in that case, we'll maximize the costs, right? And then minimum of among this. So okay, so minimax costs. So in this case, the same example, first finding the maximum for each column. So 6 and 5, you get 6. 5 and 4, you get 5. Yeah, and then you among the maximum, you find the minimum. Yeah, so this 5. Then you put star. Okay, so this is to guarantee that never receive losses greater than this 5. Yeah. So next, we have what is called saddle point. Yeah? Saddle point is an equilibrium. Yeah? It's a Nash equilibrium basically. So we call this saddle point if and only if the maximin is exactly the same as the minimax. This is interesting. Yeah. Saddle point is the game solution. This is the equilibrium. Okay. And once you find, not always you can find. If you can find, then this saddle point become the game value. Yeah. Okay. Based on that saddle point, okay, if yeah, the game have saddle point, then that saddle point become the value of the game. Okay, unless your opponent play poorly, meaning irrational. Okay, in average, you cannot win more than this value. Now, if the value of the game is positive, okay, that means this is the amount that the row will pay the column, yeah, in order to make the game fair. Yeah? That means column will always pay to the row. If this is negative, yeah, the row will always pay to the column. If zero value, okay, that means fair game. Okay, so in this example a while ago, so you put star here, you put star there, so then you get the intersection here, yeah, A, comma T, right? So the game value is 5. Okay, this is the saddle point. Okay, so in summary, okay, so these are the steps. First, you have the game matrix, okay, and then select from your own point of view, yeah, from the row point of view, and then from the opponent, yeah, from the column point of view. Remember, one lesson in game theory is you should put in other person point of view, yeah, not just from your own. Okay? And then you list the minimum in its row and then put the star for the greatest of this, and then you list the maximum in each column, and then you put the star for the least of this. Yeah? And then if the two mark of the star intersect in one cell, yeah, and have the same value, then you have saddle point. Yeah. Then that means you have prediction. Yeah. Not always you can have saddle point, but if you have, then you can predict, yeah, what will be the strategy that they will do. Okay. If saddle point exists, then the value of the cell is called the value of the game. Is it clear? Okay. So let's practice. Okay. Can you find the saddle point of this one? And what is the value of the game? Yes. 3. What? Why? Why Leicester is 3? So first, what you will do in here? Yeah. Okay, I will draw. So first, what you will do is you get the minimum in each row. 4 and 2. What is the minimum? Yes, 2. Yeah. 3 and minus 5. What is the minimum? Minus 5. Okay. So and then yeah, this is the min. Yeah. And then you get the maximum among this minimum. So 2 and minus 5, what is the maximum? This one, yeah, 2, right? Next, in here, for Mr. Column, you get the maximum. Yeah. So 4 and 3 maximum is 4, right? 2 and minus 5 maximum is 2. And then you get the minimum between 4 and 2. Okay. 4 and 2 minimum is 2. So this is the star, right? And then, oh, this is the same. This is 2 here, and this is also 2. That means you have saddle point. Yeah. Right. So, this is the value of the game, 2. Yeah, this is the saddle point. Yes. Looks okay, yeah. Clear, yeah? You see? Oh, let's practice again. How about this one? The oil. Do you have saddle point here? So, yes, the maximum is not the same as the minimax. Yes. So, then you have no saddle point. It doesn't mean that you don't have equilibrium. Yeah, there is. Yeah. But this kind of problem, okay, oh, it's difficult. I cannot find the equilibrium because minimax is not the same as maximum. Okay. So in that case, you don't have equilibrium for the pure strategy. Yeah. When we just do minimax and maximum, this is called pure strategy. Yes. Okay. Yeah. This is the result. Okay. So you don't have, yeah. This is the star. It's not the same, right? So you don't have. In that case, you will find other way. Yeah. So let's get the new technique. Yeah. It's called domination. Yeah. Domination technique. What is that domination technique? A dominant strategy, okay, is a strategy that gives you higher payoff than all of your other strategy. Yeah. The emphasis is all. Yeah. Regardless what your opponent does. Okay, so if one strategy is superior to another for all cells, yeah. Again, the emphasis is all, yeah. Either in row or in column, then that superior strategy is called dominant. Yeah. Be careful because this is zero-sum game. Okay. The meaning of dominant is different for row and column. Okay, for row, you want to maximize the value, yeah? So for column, you want to minimize the value, yeah? So because the column is actually the negative, right? So it becomes the cause. So now if domination exists, then you will reduce the game matrix, yeah, to show only dominant rows and or dominant column. Okay, so I give you an example so that you can understand, yeah? So say you have this game matrix. Okay. Now look at its row 4, 2, 3, minus 5. Yeah. So you compare 4 compared to 3 here. Which one is bigger? Oh, this one is bigger. How about this one? 2 and minus 5. Which one is bigger? Again, here is bigger. So because for all rows, yeah, this is dominant, then the dominated rows will be deleted. There, you delete this one. Yeah, empty. Okay? And then now you go to the columns. Now you have this matrix. Yeah. So 4 and 2, which one is bigger? Oh, oh, wait. This one is smaller. Yeah. So for column, you want to find smaller, not bigger. Yeah. So in this case, 2 is smaller than 4. Yeah. So in this case, you delete this one. So finally, you get only 2. Is this clear or not? So again, let's play a different way, not from row, but from column first. Okay. So I will delete this. So look at each column in the same matrix. Yeah. But now I'll play column first. Yeah. Actually, it will be the same. Yeah. So because you play column, so remember column always play equal or smaller. Let's see. 4 and 2. Yeah, which one is smaller? This one. 3 and -5. Which one is smaller? This one. So this column win. Yeah, column D win. So in this case, I will delete this first column. Yeah, become something like this. So, and then because this is already in the column, so what you will do, you compare row A and row B. Because you're comparing row, what you will do, you get the maximum. Yeah. So 2 and -5, which one is bigger? So 2 is bigger, so you delete this. So again, you get exactly the same. Yeah. What if different column with if you are not, if one column, not for all, yeah, one of the cell is winning, the other one is losing, then it's not domination. Yeah, the keyword is all. Is that clear, Lester? Yeah, if you have one column or one row is different, so not domination. Domination must be all row or all column. Again, the keyword is all. Okay. So easy, yeah. Domination not always exists, yeah, because if not all, then you cannot get. Yeah? So then you finally you can get the reduced, yeah, until one matrix, yeah. Then you get exactly the same result, yeah. So this is the one technique, yeah, domination strategy. Yeah? If you use the calculator, it will tell you whether the result of domination, what is the reduced matrix. Yeah. So this is the example of World War II, the Second World War. Yeah, very famous, called the Battle of Bismarck Sea. So this is the actual Bismarck Sea. So this is in the eastern part of beside Indonesia. Yeah. So in Papua New Guinea. Yeah. So in 1943, yeah, General Imamura has been ordered to transport Japanese troops along this Bismarck Sea to New Guinea. Yeah? And General Kenny want to bomb the troop transport. Yeah? So Imamura must choose between the shorter northern route or the longer southern route to the New Guinea. Yeah? And Kenny must decide where to send his plane, yeah, to look for the Japanese. Remember, this is 1940s, yeah. So the plane is still very small, okay, with a propeller. Okay, so if Kenny send his plane to the wrong route, yeah, he can recall, but the number of days of bombing is reduced. Yeah, so then the value here represent the number of days. Okay, so this is the payoff matrix. If you look at this, question to you, is this zero-sum game or not? It is, yeah. I just make it as if non-zero-sum game, but it is actually zero-sum. How do you know? In each cell, the sum is zero. Can you see? Okay, in each cell, the sum is zero. So this is actually zero-sum game. Okay, yeah. So how to find domination? Using domination, can you solve this game? Okay. Do you want to practice this? Domination. And you can share your screen. Yeah, if you select the row, oh, there is no domination, right? Then you try to select the column. Is that domination or not? Yeah. Equal is considered weak domination. Yeah? Did you get? Okay. So yeah, you want to find domination. Okay. Any you shall compare the row, there is no domination, right? But if you get the columns, yeah, you can see that the columns, this is equal, so the same. So here is -1 dominate -3. No, -3 dominate -1. Yeah, -1 dominate -3. Yeah. So in this case, you can delete the second column. Yeah. And then you can compare the row. Okay? So in this case, you get north. Okay? So this is actually what happened in World War II. Yeah. So this show that game theory have predictive power. Okay. So if you have the correct game matrix, you can predict what will happen. Is to validate the actual things. Yeah. So for the mouse and card game, so you can find the dominant rows and dominant columns. Okay? So it will have several steps. Okay? So for example, the cut strategy 5, yeah, this one. Hmm. Yeah. This one compared to the other strategy. So for example, compared to 1. 0 and 0 is the same, right? 1 and 0, this is winning. Yeah, 5 is winning. And then the same, this is winning, this is equal, this is winning, this is winning, winning, equal. So in this case, weakly dominated. Yeah? So this one I delete because this is dominated, so I can delete this one, and so on. So you can finally get the smaller number of rows. Yeah? Okay, and based on the columns, okay, now mouse strategy 1 dominate 5, 8 dominate 4, and so on. Okay, then you can get smaller number of columns. Okay, and eventually you get this kind of reduced matrix that you cannot reduce anymore. Okay, so domination strategy can be useful to reduce the size of the game matrix. Yeah? Finally, you get something like this. Yeah? So at this point, you cannot find domination anymore. Then you can use other strategy, other technique. Yeah. So here, the game matrix have no solution in terms of pure strategy. Yeah. So then the question is, what if the game have no saddle point? Yeah. How do you find the solution of the game? Yeah. So then this is the answer. Yeah. So the game that you play earlier is called pure strategy. What is that? That means the strategy that you stick to play in one game. Yeah. If you play the game one time, yes, you cannot find the solution. Okay. But how about like this? If you have that same game, but we play many, many times, okay, and then you can use random number to play that, okay? So if you play many, many times, then you will have what is called grand strategy or mixed strategy, yeah? The elements of the mixed strategy is still pure strategy, okay? But now you play randomly, yeah? So then this is called mixed strategy. Yeah? So the grand strategy, that the decision is based on random probability distribution for each of the pure strategy. So in this case, you set some kind of probability for each action, yeah, or some kind of art, right? So you have some art, okay, for each action or for each strategy. What is the art that you will play this one? Yeah. So here is the example. for the drilling, yeah, oil. So this is the game matrix that we have a while ago, right? Then you can put R for each action for any player, yeah. So this one is X, and of course, because only two, so this is 1 minus X, right? If this one, if no oil become Y, the R, that means if no oil, if have oil become 1 minus Y, correct? Okay, so then you can use algebra. Yeah, what is the algebra here? So you set here minus 7 times x, okay, and then 1 minus x times 1. Yeah, so in this column should be the same as 10 times x minus 5 times 1 minus x. Yeah, this second column. So for each column you should make the same. Yeah. So in this case you will get x. Now the same thing for the row. Okay. So minus 7 times y, yeah, plus 10 times 1 minus y. Okay. And then the second row is 1 times y, and then minus 5 times 1 minus y. Yeah, that's one. So this must be equal, yeah. So if you do the algebra, you will get the y. Yeah. So that x and y, you put it in the matrix. So you will get the R. Yeah. So this x and y represent probability, right? So if you want to get the R, you just multiply by the denominator, yeah, 23. So you get the R. So based on mixed strategy, okay, if you play this many times, okay, then you will sell the equipment rather than drilling, and higher probability that there is no oil. Okay. Yeah, so what is the long-term expectation of each row and each column? Yeah. So if you put that because of this R, so you can compute, yeah, the long-term expectation. Okay. And this is if you calculate for each, yeah, drilling, selling, have oil and no oil, you will get exact the same value. Yeah, exactly the same value. And this value is actually the game value. Yeah? So in this case, negative. That means it's unfair game for the row. It's always losing. Yeah, whatever strategy to choose is always losing. Okay. So very nice. Huh? So the solution is not always pure strategy. You can have a mixed strategy. Yeah. Is this clear or not? Anyone have question about this computation? So can you solve the next practice, birthday, Frank and his wife? Okay, maybe at this point still difficult for you. I will give you the trick, yeah. After this, yeah, I will give you the trick how to compute very fast. Okay, manually. Okay, that is the trick to compute very fast manually. Yeah. So wait. If you use algebra, very long, right? To compute this. Okay. Okay. Yeah, the trick is only for 2 by 2 and 3 by 3. Yeah. Otherwise, you need to use linear programming. Okay, so the result of this art, okay, this is the value. So the art is 24 to 1. Yeah, 12 and 0.5, so 24 to 1 to buy flower. Yeah, so in fact, this is actually dominant strategy, and this is the game value. Okay. So what happened? Okay. Remember, the game value of the mixed strategy represent the average, yeah, the average payoff. It is always the same, yeah. So okay, so how to compute this very fast? Yeah, how to compute this very fast? Yeah, this is only for 2 by 2. Yeah, we can use rule of thumb. Yeah, the technique is very simple. Yeah, this is like high school technique. Yeah, so what you will do is you find the difference between row, okay, and get the positive value, and then you reverse to get the R. Yeah, here example. Yeah, so you get this one -7 and 1. Okay, the difference is -7 minus 1, so you get -8. Yeah, the same here. 10 minus 5, so you get 15. Okay, so this is 8 is negative, so you make it positive. Yeah, so 8 and 15, and then you reverse. Okay, so when you reverse, right? So you get the R. The R of have oil and no oil is 15 to 8. Yeah. So 15 become no oil, 8 become have oil. Yeah. Reverse. And then for the R for row, the same thing. Yeah. But you find the difference between column. Okay, so -7 and -10. So in this case, -17. Yeah? And then 1 and -5. So -5. Yeah. So become 6. Yeah. Again, you ignore the negative value. Okay. Make it positive, and then you just reverse. So the art now become 6 for drill, and then 17 for selling equipment. Yeah. So then you will get that value available. This one, exact. Is this clear or not? Okay. If this is clear, okay, so you practice, yeah. So I want you to practice this one. Can you find the art? Very fast to compute. So find the difference. Okay. And then you reverse. Yeah, make it positive, and then you reverse. That's it. Okay. Then you try. So you take the difference, yeah, 3 minus 2, right? 1, and 1 minus 4, so minus 3. Okay, and then 1 and 3, so you reverse. So you get 3 and 1 here. Okay, 3 and 1. The same thing here for the columns. Yeah. 3 minus 1, 2. 4 minus 2 minus 4. So then you get the same. Okay. Then you calculate the game value. So you will get 2.5. Okay, so this is the art that you can use the simple technique. Yeah, this is only for 2 by 2. Okay. Okay, for 3 by 3, a little bit more complex. I don't know if you want to do this. Yeah, you need to do the cross product. So using this one, yeah, AD minus BC. Yeah. So and then you need to get the absolute value of this R. Yeah, you can read by yourself how we compute this. Yeah. Anyway, I don't recommend to use this directly, to use calculators better. Yeah. For 2 by 2, yes, you can do it very fast. Yeah. So yeah, this rule of thumb is only for 2 by 2 and 3 by 3. So then I think this is developed very old time, yeah, before there is computer. So they want to calculate very fast using hand. Yeah. So for other size of matrix, you need to get using algebra, or with Excel now you can use this called linear programming. Yeah. So in linear programming, basically what you will do is you set the probability. Okay, the sum of probability must be 1. Okay, and then you compute the value for each row. Yeah, the payoff multiplied by the probability. Then you use solver. Yeah, in Excel. So here is one of the example that you can do minimax equal to maximin, right? And this must be 0, isn't it? Then you sort the probability. Okay, so subject to this constraint, and that the probability must be 0 between 0 and 1, and the sum product of the probability and the payoff must be also 1. Yeah. But be careful, because you are using solver with this basically Newton method. The initial values of the probability matters. Yeah, you may have different values result because of this choice of initial value. The algorithm have some problem. Okay. You want to get the value of the game in this one, right? So basically, if you have, I'll give you the example here. Okay. If you already know the the art, right? So the art of drill is okay, the art of the drill is here. You have 15 times minus 7, 15 times minus 7, and then plus 8 times 10. Yeah, so the art of the drill is the art of the columns multiplied by the value, and the art of the drill multiplied by the value. Okay. The same thing, yeah. If you have the selling equipment here, then you will multiply 15 times 1 plus 8 times minus 5. Okay, so 15 times 1 and 8 minus 5. Yeah. Of course, you can divide by the sum of this 15 plus 8. And that's the probability. Okay. The same thing, if you want to get have oil, okay, then you will have 6 times minus 7 plus 17 times 1. Okay, 6 times 10 and 17 plus minus 5. Okay, here. So this one have oil. So regardless what you choose, either row or column, yeah, if your computation is correct of the art or the probability, you will get exactly the same. Yeah. So you will get all the same for rows and columns. Okay. So that's how you compute. Okay. So with this, let's end here. Okay. Next meeting, I will discuss about the scaling. Yeah, but you can also read by yourself. Anyway, I will explain the scaling next meeting. Okay. And some of you gave me the email about the last anonymous asynchronous class. So let's discuss it next meeting also. So please read before the class on the next topic. Yeah, which is non-zero sum game. Yeah. Okay. Oh yes, I can adjust assignment time to be next time. Yeah. Which assignment you are trying to adjust? Really? Mhm. So please read the slide on non-zero sum strategy game, the threat and credibility, game of trust, and system control. Yeah, based on game theory. That's mechanism design. Yeah. How you will select your own game. Yeah, that will be next meeting. Yeah, I can adjust. You list to me or email me what assignment I need to adjust. Okay, then I can adjust for you. No problem. So thank you for today.
Thank you,
And
sir.
see you next meeting. Next week, is that?
Yes, sir. Yes, sir.
Okay.
Thank you, sir.
Good.